Okay, we are going to take a very quick look at linear approximation using derivatives to approximate a number that might be difficult to do just by guess and check, repeated guess and check of the fifth root of 100,000 and 125 would take you a long time. But if we say, hey, suppose we think about this as if we graphed it, okay, and a fifth root curve would look something like this. And if we're way out here at 100,000 and 125, and then we're going to take advantage of what they call local linearity, that if we simply find the derivative, the slope of the tangent line, and then put that tangent line right on that point, and then if we get really, really close to it, they're not going to differ by too much. If I zoomed in on that, right, and here's my curve, and there's my slope of that line, and I stay close by it, this will be very, very, very close. So I just start by saying, all right, suppose f of x is x to the 1/5 power, all right? That's my original curve. And then if I take the derivative of that, f prime of x, well, that's pretty easy. That's 1/5 x to the minus 4/5, all right? Well, I need to find a point that's nearby that I know that's convenient, and this is where it's a little bit made up. It's teachers try to give you something that is pretty straightforward. The fifth root of exactly 100,000, right? There would be 5 zeros there, and we should be able to do that in our head because for every zero that you're getting in a power of 10, you would have 10 to that power. So this is very, very close to a point that would be 100,000. Make sure I get number of zeros, and then 10, right? So the fifth root of 100,000 is 10. So the fifth root of 100,000 plus 125 is not going to be too much bigger than 10, but it's hard to guess what that decimal might be, all right? So what we need to do then is sort of take and put this ideal point, like we've already done it in there, the fifth root of 100,000 is 10, but we also then can put it in here. And what was that? That's going to tell us the slope, m, is going to be equal to f prime of our 100,000. And what is that? Well, it's 1/5 of 100,000 to the negative 4/5. That bottom number is still the root number, and we've just done that. So we know that it's going to be 10 raised to the negative 1/4 power. Well, that's just 1 over 10 to the 4th. That's 1 with 4 zeros, okay? So when I plug this in, I get that. Well, that's my slope then. So my slope, m, is 1 over 50,000, okay? Well, it helps to go back and think about what is slope. Well, slope is defined as the change in y, delta y over delta x. So we know that this slope is going to have some delta x and then some delta y, and the ratio of those two give me my slope, which I know is 50,000. So if I'm here at a test point that I know that if I go out 100,000, I would go up to 10. I'm just going to go a little bit further and a little bit further up, and that should give me my very, very close. That differentiation is not going to be too far. If I go to 100 and 125, then I can find my value of the root there. So what do? So I can just say I'm looking for what that delta y is, because whatever that delta y is, I'm going to tack it on to my previous value of y, and I'll be good to go. So I multiply both sides by delta x. So I simply multiply this by 125, because that's how much my delta x is. I've gone over an additional 125. When I multiply this, I get a 5 to cancel, and divide 125 by 5, and I get 25. I'm just going to cheat and give me that. So I get 25 over 10,000. All right, well, that's 4 zeros. I can put the decimal point there. Put the decimal point there. If I move it 1, 2, 3, 4 to get it under 1, that would be 1, 2, 3, and 4. And I've got 0.0025. So I know my approximation for that answer is 10.0025. because I just take my original 10 and I add on the delta y amount, and that's where I would be. If you put that in a calculator, which we can do, I guess, turn it on, clear that, I would say 10,000, I need one more zero, right? Nope, I got it, 125, and I raise that to the 0.2 power to the 1/5, there it is. So it's very, very close. You can see, whoops, you can see right there, very, very close to 0025. Thank you.